graph of the function in a polar coordinate, r is equal to 2 plus 4 sine theta. So now let's plug in here when the theta is a 0. When theta is a 0, instead of the theta I'm plugging 0, sine of the 0 is a 0. Time 4 is a 0, plus 2 is 2. So the point here is a 2. So this point is 0. So now I'm going in a pi over 6. If I'm plugging pi over 6, it's going to be sine of pi over 6 is 1.5, 0.5. Time 4 is 2, plus 2 is 4. So this is easy to calculate. We don't need a calculator, but for pi over 3, because we have a square root of 3 divided by 2, and this one we need a calculator a little bit. So let me go in a calculator quickly. And square root of 3 divided by 2, because pi over 3. So just let me go in calculator just to make sure. Pi divided by 3. And we are going in the sign. So just let me put in the radian. And I'm looking for the sign. It's 0.867. So this one means is the square root of 3 divided by 2. And time 4. Time 4 is equal with 3.46 plus 2 is 5.46. So this value here is 5.46. So this is a 5 and 6. 4, 5, 6. So it means it's between 5 and 6. So in this line here. So pi over 3. If we are plugging pi over 2 in a sine theta instead of the theta, sine of pi over 2 is 1. Time 4 is 4 plus 2 is 6. So this is easy. If we are looking at to check the symmetry with respect to the line pi over 2, we have to exchange in the original equation minus r and minus theta. So those variables we have to exchange. So the angle and the radius. But if we are exchanging here, we cannot get the original equation even we are multiplying by minus 1. So the symmetry, test of the symmetry does not hold with respect to the line pi over 2. If we are looking with respect to the pole, so this is the pole, this is a line here. If we are looking with respect to the pole, do we have a symmetry? This minus r and theta, we have to exchange those variables. But if we are exchanging again, it's not going to hold. Even if we are going here to look for axis of symmetry in a minus theta and r and minus theta, we are exchanging here. And we cannot find the symmetry. So the test of the symmetry does not guarantee is going to be symmetrical with respect to the line pi over 2 or with respect to the pole. Anyway, we are trying to find individually every point. In a 2 pi over 3 here, if we are plugging 2 pi over 3 because of the sign is in the upper side, is going to be positive value. And a 2 pi over 3 is going to be square root of sine of 2 pi over 3 is square root of 3 divided by 2, which turns out to have the same value like a pi over 3. And if we are calculating everything, we are going to get the same value. So I'm not going to spend more time here. So I am just copy this point, and it looks like we are going to have a symmetry with respect to the line pi over 2. Now in 5 pi over 6 in a sine theta, we are going to get the positive value here, 1.5, and 1.5 times 4 is 2 plus 2 is 4. So and this point here is a 4. So it looks we have the symmetry. But if we are plugging a pi now, and the sine of the pi is minus 1. Minus 1 times 4 is minus, I'm sorry, the pi is 0. Sine of the pi is a 0. Time 4 is a 0. Plus 2 is 2. So we have the same value. I'm sorry about that. So now we can connect those points and let's see what we get. If we are connected those points, so let me go slowly. If we are connected to all this point, we get something figure like this. So this figure, and this figure is symmetrical with respect to the line pi over 2. So we already see from the practical, finding practically those points, it turns out this figure that we get from this polar equation, we have a symmetry with respect to the line pi over 2. But now if we are taking, for example, if we are taking a 7 pi over 6, 7 pi over 6, let me use a calculator here because we need to use a calculator. Let me go 7 pi. 7 times pi divided by 6. We get this value, and let me go with the sign. We get minus 0.5, and minus 0.5 times 4, let me go here, times 4, is minus 2, and plus 2 is 0. Plus 2 is 0, so this value gives us a 0. So right here. Same thing we are going to get with the 11 pi over 6. It turns out to have the same because we have a symmetry with respect to the line pi over 2, so it's going to give us the same. So I'm not going to extra calculate here. But now I'm going with the 4 pi over 3. What do I get in the 4 pi over 3? Let me see. 4 times pi, we get this value here. Divided by 3, we get a 4. And now let me go here in the sign. I get a minus 0 point is minus square root of 3 divided by 2. Times 4. Times 4, we have a negative 3.46 plus 2. Plus 2 here. And is minus 1.46. So minus 1.46 is not in the positive side, but in negative. So it turns out to go on the other side. So, and it goes something is a minus 1.5. Here is 1 and 2. Minus 0.46 is around the minus, is around here 1.5. So let me check again. Is 1.46. I would say it would be between 1 and 2 is around. Because it's negative, it doesn't go on this side, but goes in the opposite side. It's here. And now we are looking, for example, a 3 pi over 2. In 3 pi over 2 is going to be minus 1. Minus 1 times 4 is minus 4. Plus 2 is minus 2. But because it's a minus, it's going to be in this point here. Okay, so it's going in opposite side. And as I said before, in 5 pi over 3, because it gives us the same value like a 4 pi over 3, is going to get a negative and is going the opposite side. So just let me see, did I write this? Did I find this correctly? 4 pi over 3 is here somewhere, I'm sorry. Okay, because lines up with a pi over 3. So because I didn't put it correctly. And now 5 pi over 3 goes same like in this point here. Minus 1.46. And we have these values. And now, because we have a symmetry here, let me connect those points. So those points goes like here somewhere. Connect in here. And we get a Limacons. This is a Limacons figure. Whenever this is A, this is B. Whenever is A divided by B is less than 1, we get this form of the Limacons. We get this form, and we call the Limacons. Okay, but now, for example, if instead of the sine theta, we have a cosine theta, r plus 2 plus a cosine theta, we're going to get the same figure, but this figure is going to be rotated for 90 degrees in this side. It's going to be here. It's going the same figure, but it's going to be in this side here somewhere. And here I would stop.